Hello, my name is Alex Gonzalez, and this is a series of coding skills that I'm showing and recording, so it can be useful to anyone to learn a little bit more and understand the basics of different topics. In this case, today I'm going to be talking about binary trees. As usual, I'm going to share something really, well, not super personal, but something that I learned recently, and I discovered my passion about tea. So I've been drinking tea since maybe 1 year ago, and even if I don't know the benefits of different types of teas, I can say that it feels good. It feels better. My body has responded pretty well instead of coffee or any other sugary items. I just don't add sugar, but some other sweeteners such as Splenda or so, and it's really good. I highly recommend it. And the best and my favorite is from Trader Joe's. It's a chai latte, so it's a mixture of tea and latte, but it's delicious. It's my favorite. I highly recommend it if you want to take it. Now, let's go to the business. So, as usual, I already have a skeleton of what I'm gonna be coding. I have a struct node with a value, and the binary tree is gonna have 2 pointers, one to the left and one to the right. And I'm gonna create a random tree. I'm gonna insert a node. I'm gonna print the tree from the left. Let's say left. And these operations are gonna be done or called in the main function over here. So I have the skeleton of my functions here as well, and I'm gonna update this one, which is the left. So to start with, I'm gonna do something really quick, which is the binary tree message over here. So I'm gonna create 10 elements as a random tree. I'm gonna print a tree from the left, and then I'm gonna print the tree from the right. There is one extra function that I know that I'm gonna be using, which is insert node, that I'm gonna use when I'm creating the random tree. So the first thing that I'm gonna do is to create struct node index equals to head, which is going to be here. I'm missing this. Now, I'm gonna create a new node and 10 times. So I need my loop. It's less than here I'm doing something wrong. Total. I should be explicit. I like to be explicit. So I'm gonna need a new node that has a memory allocations of and then, as usual, I'm gonna initialize to null left and right, and the value that I'm going to be populating is going to be a random value. New node val equals to rand. I'm going to do a mode 50. This is going to help me to create random numbers, and the mode is going to help me to go from the range of 1 to 50. Even if it's going to be only 10 elements, 10 elements is just an example, but or 10 nodes. But yeah, I just want random numbers there. So once I have this, I need to insert a node, right? Because I have the node already here with all the values. So I'm going to call the insert node function, and it's going to receive the new node and the head, which is explicitly described in the parameters over here. So why am I doing this in a different function? The reason is that what I want to do is to create an iteration on the same insert node. So basically I'm going to be updating the head whenever it's possible. So to start with, if head equals to null, then obviously we need to say the head it's equal to the new node, and that's it, right? That's the first element. So when we go actually this is not yet recursive, maybe not. Okay, so it's not. So let me see. So if it's not null, we need to make sure that okay, I got distracted for a second, but what I want to do is to see if the element is going to be added to the left side or the right side, but that depends on what's going to be the head. Okay, so if the new node fill val is greater than the head val, this means we need to insert to the right. So, but we need to know if there is nothing yet on the right side. Because if I do it this way, I cannot immediately get there. If head right is equal to null, then then we need to say that head right it's equal to the new node, else if it's not null, then we need to say that we want to insert, we want to use recursivity, node, sending the new node, but now the new head in the next recursion is going to be the head right. So in the same sense, let's do greater or equal. In the same sense, if it's not greater or equal, then we're going to do something very similar, but to the right. So I'm going to say to the right, to the left, I mean. It's equal to null. I'm going to say that the null left is here, and I'm going to take this to evaluate to the left. And that's it to insert a node. And the way that recursivity is going to end is by the element of null. Whenever it reaches null, it's going to get there. So in order to print this, let's do it first from the left. Basically, I'm going to receive the head, and I'm going to move immediately as much as possible to the left, which means that if head left equals, if it is not equal to null, then I'm gonna print left, moving or passing the head left. And after this, I'm gonna visit the right. So I'm gonna visit the right side and print it if it's not null. And finally, once I visited the left and I visited the right, I'm gonna print F, the current one, right? The one that I am in, I mean the head that I am at. So it's gonna visit the left, it's gonna visit the right, and then it's gonna visit the head or the parent of those two. So I'm gonna print F. Oh, I have a button that is making me crazy. So I'm gonna say head. I'm gonna say node, just node. The value, and I'm gonna do this. So this is the line that is gonna be printing what we are visiting. At some point, if we are going to the left and it's not null, then it's gonna visit until the left is null. It's gonna pass and then try to visit the right. And again, it's gonna look into left and then coming to the, I mean, it's coming to the right, but visiting first the left pointer of the right node, and at the end, it's gonna print the node. I think that's it. Let me check really quick for compilation errors. I don't find any. So I have head is a new node, head is insert to the right. If if head right is equal to null, then I think, well, let's try it out. This is the last exercise we had. Now I'm gonna cc binary 3-o binary t. Whoops. Okay. So 42. Oh. I think yeah. Now number 49. Insert node. I think I am. What's going on? 49. Passing argument 2. Insert node from compatible pointer. I'm sending. Okay, so I'm not sending the address of this, but I should. I mean, from the right pointer, which is going to be the same here. I was passing the pointer itself, and that's not right. 64. It says invalid type argument. Okay. Oh, okay. So I don't need to do this because this is just a regular pointer. It's not an address. Same here. 69. Yeah, one more. Whoops. Okay, binary t. Let's see. Interesting. So we have. So if now that I don't have lots of entropy here, you're going to see that every time that I execute this is going to be the same numbers. So I'm going to write this down really quick because the first element is going to be 21, and then the next is going to be 15, and then actually I'm already printing them in visiting them by the left side. So what I want to do is to see first how it was populated at the beginning, and let's see. Insert node. Comes here. Insert node. I think here. Yeah. Print f. I'm just going to print the values that are being created and what's the order while being created. I want to say random. New node. Yeah. So okay, so we have 33 as the first element. I'm gonna do the 3 as it is. So I'm gonna make this bigger and I'm gonna show you how it's gonna look. Something similar to this. This is gonna be the tree. And based on this, I'm gonna write down what's supposed to be the visit from the left is going to be 15 and 27 and 30. Then, no. Yeah, 15, 27, 36, 35, 42, 49, 43, 36, and 30. Oh, there's a 21. Okay, so I did something, yeah. Okay, 21, 15, 27, 35, 42, 36, 49, 43, yeah, 36 and 30, and 33. Oh, I did it wrong. The first one was 33. I did it wrong, so yeah, this is right. So yeah, basically what I am showing in the screen over here is the result that I was expecting. So it worked pretty well the first time. Now it's, since we already have the visit from the left, it's very simple to create the visit from the right. So I'm just gonna copy and paste here the visit from the left, but I'm gonna change the order here by visiting the right first. Then visiting the left, but on the right function, and finally printing this. And if you want to make it this shorter, you can just remove this, and we are gonna end up with a very really clean function, or lean function. So I can just do the call. Actually, it's there already, the call to print on the right. I'm gonna say here left, right first. Okay, I did something wrong. And when copying, pasting, right, left. Oh, I'm moving this. This is not supposed to be the left. This is supposed to be the right, and this is supposed to be the left. Yeah. Okay, so we have this, and the output should be, let me write it down. Visiting on the right is going to be 49, yeah, and then 42, 43, 36, 35, 36, 21, 15, 27, and then 33. So 49, 42, 36, 43, 35, 36, 21, 15, 27, and 33. So just like I do this one that I'm showing here. It's the output that I'm expecting. So it works. That was kind of easy and short. And yeah, that's a binary tree. Again, I'm going to talk about the usage that you can have for this. Social networks is pretty useful. Or, yeah, I'm going to add some examples later in a single video with all the data structures that I've been working with. For now, I'm going to leave it there, and I hope you enjoyed. I did. It's a new day. It's very early in the morning, ish. It's 9 a.m. on December 15th, and Christmas is coming, so hope you enjoy.